So today we're going to start our last unit of the year. It's going to be on circles. A circle is a set of points that are all the same distance from a given point, and that given point is called the center of the circle. In this diagram we have point A, and our circle consists of all the points that are a certain distance from that center, and that distance is called the radius. So if I travel from A to B or A to C, that distance is exactly the same, and like I said, it's called the radius of the circle. Today specifically we're going to talk about central angles, and a central angle is an angle that has its vertex at the center of the circle, like angle BAC. And we're going to learn that the measure of the central angle, angle BAC, is equal to the measure of the intercepted arc. An arc is just a section of a circle. In this case we have arc BC drawn. And to name an arc, we use an arc symbol, similarly to how we use a segment symbol when we talk about a section of a line. So an arc, like I said, is just a section of a circle. We almost only talk about minor arcs, but occasionally you'll be asked about a major arc. A minor arc is the shortest distance between 2 points along a circle. So if I was talking about this section in red right here that travels from A to D, that would be called the minor arc. The major arc is the long way from A to D. To name a major arc, you typically need to use an extra point along the way to tell the reader to travel from A to some other point before going to D. So in this case, arc ABD is the major arc because it's the long way from A to D. So, as I've already mentioned, the measure of a central angle of a circle is equal to the measure of the arc it intercepts. So, central angle BAC has its vertex at the center of the circle, and its measure is equal to the measure of the intercepted arc. So, it's equal to the measure of arc BC. Here, we were asked to find the measure of each central angle. We were given the measure of the intercepted arc. So since I was given the measure of arc RW is 72 degrees, I'm able to conclude that the measure of angle RVW is 72 degrees. On the right, I'm told that the measure of arc PQ is 65 degrees. So I can conclude that the measure of angle PCQ is 65 degrees. Down here in the lower left, I'm given that the measure of arc BF is 136 degrees. So I know that the measure of angle BGF is 136 degrees. Remember, the measure of the central angle is equal to the measure of the intercepted arc. Down here in the lower right, I'm given that the measure of arc EC is 120 degrees. So I'm able to conclude that the measure of angle EDC is 120 degrees. This is more the type of problem that I would expect you to be able to solve. We were given the diameter of the circle. A diameter is a segment that connects 2 points on a circle and passes through the center of the circle. Since we're given diameter segment BCD, we know that that divides the circle into two semicircles. Each one measuring 180 degrees. An entire circle is 360 degrees, and that's going to come into play in this problem. We're given the measure of angle ACD, that being a central angle, because its vertex is at the center of the circle, is 35 degrees. And the measure of angle ECB is 96 degrees. Again, that's a central angle. And we're given this huge list of things to find. Very commonplace in these circle problems. So with the circle problems, I almost always find everything and then go back and answer the questions. So since I was given that the measure of angle ACD was 35 degrees, I easily conclude that the measure of arc AD is 35 degrees because the measure of the arc has to be the same as the measure of the central angle. Since I knew that the measure of angle BCE was 96 degrees, I know the measure of arc BE is 96 degrees. Now I'm going to use the fact that I have this diameter. So since I have diameter BCD, I know that this half circle has to measure 180 degrees. So if I take 180 and subtract 35, it leaves me 145 degrees for the measure of arc BA. And since arc BA is 145 degrees, angle BCA is 145 degrees because the measure of the central angle is the same as the intercepted arc. Another way that you might consider this is that angle BCA and angle ACD are a linear pair, and therefore they have to be supplementary, which means their measures have to add up to 180 degrees. Either way works. Similarly down here, I know that the measure of angle BCE is 96 degrees. So if I take 96 away from 180, that leaves me 84 degrees for angle DCE. And arc DE has to measure 84 degrees because the arc has to measure the same as the central angle. So based on just copying off the diagram, I'm able to conclude that the measure of angle ECD is 84 degrees, the measure of angle ACB is 145 degrees, the measure of arc AB is 145 degrees, the measure of arc AD is 35 degrees, the measure of arc DE is 84 degrees, the measure of arc EB is 96 degrees. These last two require just a teeny tiny bit of work. The measure of angle ACE, that travels from A to C to E, will have to be the sum of its parts. That's the partition postulate. So we'd have to add 35 plus 84 to come up with 119 degrees. And for the measure of arc EBA, that's going to travel from E to B to A, will again be found using the partition postulate. 96 plus 145 gives me 241 degrees.